Hi, my name is Xingyu, and I'm presenting Scenario 2 on search pricing and hotspots. Here's a quick overview of what I'll be covering. Program needed to fulfill the 6 deliverables. Firstly, allow the user to enter the day of week as filter criterion, tabulate the 5 pickup areas with the highest average search multiplier for that day, generate a dynamic analytics conclusion based on the table results, allow the analysis to loop continuously, and generate a summarized analysis across all user inputs. And lastly, my value add, which is comparing the average search multiplier for 5 weekdays versus weekends for the top 5 hotspot areas. The program starts by loading and cleaning a CSV file. Then it displays a menu and gets user input, validates that input, handling case sensitivity and blank entries, and filters the records chosen by day. From there, it groups the matching trips by pickup area using a dictionary, calculates the average search multiplier per area, sorts the results using a selection sort, and prints the top 5 table along with a dynamic conclusion. This loop repeats until the user presses enter with no input. After the loop ends, 2 additional steps run, which is the weekday versus weekend comparison and a session. Now, I chose to read the file manually using read lines and split comma because this file reading using open and read lines is what we learned in week 7. And I wanted to show that I understood the CSV files work at the line level, not just abstracting them away with a module. I find the column positions by calling headers index on the header row. This means the code still works correctly, even if the column order of the file ever changes. For error handling, I use the accept value errors specifically, not just accept alone, because when I use accept alone, it will just kind of swallow every error, and then including the ones that I want to know about. By catching only value error, I'm actually allowing that if this specific value cannot be converted to a float, you should skip that row. This program also counts how many rows were skipped, and then it reports it, so the user isn't in the dark about the quality of the data being loaded. Each value record is stored as a list of 3 values, the date time string, the area name, and a search multiplier, and appended to the records list. Yes. Print conclusion generates a dynamic written summary using if and else if logic, and it compares the spread between the 1st and the 5th ranked area to determine whether the search is concentrated or broadly distributed. The thresholds of 0.05 and 0.20 were chosen because search multipliers in this dataset range roughly from 1.0 to 2.0, so these represent 5% and 20% of the range respectively. Here you can see a sample output of the program. When the user enters Wednesday, the program filters all Wednesday records, groups them by pickup area, calculates the average search, and displays the top 5. Downtown Core ranks first with an average search of 1.8821 across 312 trips. Templates is flagged with an asterisk because it only has 8 trips on that day, so the result is not exactly reliable. The dynamic conclusion below the table is automatically generated, and it identifies the top area, states the gap between the 1st and 2nd place, and comments on whether the search is concentrated or spread out. Below that is the value add output. Here's my value add analysis. The weekday versus the weekend search comparison. The key design decision here is that the function only runs once after the main loop ends and not inside of it. If it ran inside the loop, it will actually rescan the entire dataset for every single query, which is inefficient. Areas like Downtown Core search high on weekdays, likely driven by commuting demand when people need to get to work, and areas like Orchard search high on weekends because people like to shop over the weekends. This gives the marketing director 2 separate sets of recommendations rather than one blanket. The dictionaries were far more powerful than I expected. I had initially assumed that I would need something like Pandas or Excel, but actually I could group search totals by area and compute the averages. Second, using accept value errors rather than the bare accept makes the logic clean, and it makes it very transparent, and this program reports it rather than skipping it. And thirdly, breaking the program into functions makes it easier to debug by finding out which area is broken. Finally, this project reminded me that Python is a tool for analysis, and it's not a decision maker. It could only tell you what happened, but the human judgment is still required on what to do with it. Thank you.